This is Logan Hall with the Eastern Shore Regional GIS Cooperative, and you're watching a video tutorial on how to generate contours in ArcGIS for desktop. Appropriate usage for contours can be used for base maps and general topographic visualizations. Contours should not be used in place of point cloud data or DEMs for surface analysis. Our objectives in this tutorial are comparing raw versus smooth contour lines, generating contour lines in ArcGIS for desktop, and building a contour index. Contour lines are used as a familiar media for representing the elevations of a land surface above sea level. These lines are typically used for base maps and general topographic representation. Contour lines do this appropriately. Contours should not, on the other hand, be used for analyzing the surface elevations above and beyond for aesthetic purposes. Typically, when someone mentions contour lines, the first thing they think of is a topographic map with smooth, rounded curves, such as the following example. The problem with the sample shown resides with the fact that it inaccurately represents the land surface. The point cloud is interpolated to a DEM, which is then further interpolated into polylines. In this particular dataset, the DEM has been smoothed through a process of focal statistics. From this resulting raster, polylines are generated, creating smooth contours. If contour lines are generated from the raw DEM, we can expect them to look similar to this. If smooth contour lines are in fact the desired final product, we must do so with a data-driven process. This is critical to preserving the data's accuracy and minimizing the level of error. We should not generate contours and smooth the vector lines after they have been built. This method does not determine the direction and level of smoothing based on the DEM or the elevation values themselves. This would be an incorrect method of smoothing, since it is not data-driven and therefore nullifies the accuracy of our already interpolated data. The appropriate method for generating smooth, data-driven contour lines is by smoothing the input DEM using a tool such as focal statistics in ArcGIS for desktop. The resulting output will be data-driven and will allow us to build contours at different levels of smoothness. This leaves control at the user's hand. In this tutorial, we can assume that you are familiar with accessing the Maryland LiDAR image services as well as extracting from image services in ArcGIS for desktop. For more information on these previous tutorials, please refer back to the appropriate documentation. We'll start off by bringing in our exported raster dataset. This is clipped from the Baltimore County DEM in meters elevation units. And we need to check to make sure our Spatial Analyst extension has been turned on. So Customize, drop down to Extensions, and make sure our extensions are activated, particularly Spatial Analyst. Since our DEM is currently in meters elevation units, we need to convert this to feet. So using the Raster Calculator Spatial Analyst geoprocessing tool, we'll double-click our layer variable. Using the icons within the window, we'll use the multiplier and 3.28084 for the conversion from meters to feet elevation units. Select your output workspace folder and name your output raster. We can remove our original DEM in meters elevation units. And in order to create smooth contour lines, we first need to smooth our DEM to ensure the vector output is data-driven. The most efficient way of doing so in ArcGIS for desktop is by using the Focal Statistics tool in the Spatial Analyst toolbox. Using the search bar, select your Focal Statistics tool. Our clipped Baltimore DEM in feet elevation units will be our input raster. Navigate to your output workspace folder and name your output raster. In this case, we'll name it _9, since we'll be using a 9x9 neighborhood for the focal statistics. Ensure neighborhood is rectangle with a height of 9 and a width of 9, and then click OK. If we turn the layer on and off, you may not notice any significant difference between the original DEM in feet and the new DEM run through focal statistics. However, this output raster should not be used for any processing other than aesthetic contour building. Using the search bar, we'll search for Contour Spatial Analyst tool, and we'll generate two contour datasets. The first one, Focal Statistics Smooth DEM. Navigate to your output workspace folder and name your output feature class. Contour interval of 1, and click OK. Note that contour lines can be very large depending on your area of interest. Therefore, it is recommended to work within a file geodatabase in ArcGIS. Countywide contour lines at 1 foot intervals can easily exceed the 2 GB limitation set on shapefiles. So for the second run, we'll use our baseline DEM in feet without focal smoothing. We'll navigate to our output workspace folder, and we'll generate a new file geodatabase. Double-click to open your new geodatabase. And name your output feature class. Contour interval of 1, and click OK to run. We turn off the baseline DEMs and zoom into an area. We can see the smooth contour lines in comparison to the raw contour lines. Indexing your contours after they have been generated is an efficient way to set up labels and symbology across multiple intervals. First, we'll bring in our contour dataset. Right-click the dataset and open Attribute Table. Under Table Options, we're going to add a field named Index. Type short integer and click OK. Right-click our new field and open Field Calculator. If you're outside of an edit session, just click Yes. And we're going to set up a modulo operation for our expression. which will be index equals contour space MOD parentheses 10. In computing this modulo, we'll return the remainder of a number after dividing it by another. In this particular expression, we set a modulo of 10. A value returned of 0 will indicate the 10-foot interval or index for the contour lines. Click OK, and close the attribute table. From here, we can select our 10-foot index using the select by attributes, where index equals 0. Click apply. Or, in clear selection, navigate right into the layer properties by double-clicking or right-clicking, access layer properties. And we'll set up index labels by first checking label features. In the drop-down, we'll define our classes. Our label is going to be contour. And using an SQL query, we can select contours where index equals 0. Click apply to check our labels. And zoom in. Now we can go back into layer properties. Under symbology, we'll select categories. The value field will be index. We'll add a single value. For index equals 0, we have 10-foot contours, so click OK. Double click the symbol. We can set this to whatever we'd like. In this case, we'll do color red with 2 width, and then all other values will be colored black or gray with the width of 1. We click apply and click OK. Now see we have a 1-foot contour dataset with highlighted 10-foot intervals that are labeled accordingly. For additional resources, please visit imap.maryland.gov, and to access your Maryland LiDAR topography server, visit lidar.geodata.md.gov/imap.